Hi, this is Mrs. Kidman, and in this video, we're going to be talking about how we can calculate combinations. So a reminder, in the previous video, we talked about permutations. Permutations are objects that are an arrangement of objects where order matters. Now, a combination is an arrangement of objects where order doesn't matter. So what we want to talk about here is count the possible combinations of two letters chosen from the word wolf. Well, before, order mattered. So WO was different than OW. But in this case where order doesn't matter, those are the same thing. So let's talk about what all of our options are. We've got the option WO, WL, WF. We've got the options OW, which doesn't count, OL, OF, and the option LF. So total, we only have 6 outcomes. Remember when we were selecting 2 from the word wolf, we had 12. So we actually have half the number of outcomes where order doesn't matter. So the way that you calculate a combination of something is we take the number of combinations of n objects taken r times. Oftentimes we say choose. So I have n items and I'm choosing r of them. Now, how I calculate what that is we can use that function in our calculator, but really what we're doing in our calculator is we're doing n factorial, or the number of objects that we have. So in this case, for our example, 4, over 4 minus the amount we're choosing, which in this case is 2 factorial, times that number we're choosing factorial. So this one comes out to be 4 factorial over 2 factorial times 2 factorial. Well, 4 factorial is 24. Divided by 2 factorial, which is 2, times 2 factorial, which is 2, and 24 divided by 4 equals 6. So we can get that. Now, if you wanted to calculate this in our calculator, what you're going to do is if you have a TI-84 or a TI-83, you're going to go down below the green alpha button and hit the math button. Then you're going to arrow over with your right arrow key on your little keypad 3 times until the black PROB or the PROB letters are highlighted in black and the font's white. Then you're going to go down and your third option should have this NCR, or N combinations or N objects for a combination where we choose R of them. And we can type in that 4 items, we're choosing 2 of them, and we get 6. So those are 3 ways we can calculate them. We can write them out, which is not going to be a successful way when we start getting hundreds of thousands of ways to do something. We can calculate it using factorials, or we can use our calculator. So let's take a second to calculate these 3 different combinations. I'm going to do it in my calculator, but again, you can do it by hand. So we're going to find 5 combinations of 3, or 5 choose 3, and there are 10 combinations of those. I'm going to find 7 combinations of 4, which comes out to be 35 options. And then we have 8 combinations of 2. So as we find that 8 combinations of 2, what we end up with is 28 options. And so that's how we find those combinations. Now remember, we actually did these same things in the previous video. 5 permutations of 3, 7 permutations, 7 permutations of 4, and 8 permutations of 2. And actually, as we calculated that, you'd be surprised by how big those numbers are and how they vary. So combination versus permutation, that order really does make a huge difference in what we're calculating. For example, 5 permutation of 3 is actually 60, so 6 times smaller. 7 permutations of 4 is 840. And lastly, 8 permutations of 2 is 56. So notice how these numbers vary so much. So our permutations versus our combinations divide by 2. This is a huge difference. The relationship between 840 and our 35 come out to be 24. So there's 24 times bigger, or 6 times bigger. So it really varies depending on what we're looking at. So now what I want to do is take a look at a couple of word problems where we practice finding combinations and use those combinations to do some calculations. So let's take a look at this first one. Each year, 64 golfers participate in a golf tournament. The golfers play in groups of 4. How many groups of 4 golfers are possible? Now remember, permutations mean there's a specific thing we're looking for. First place, second place, third place, president, vice president, computer programmer, software engineer, whatever it is, we're looking for something specific, so our order matters. In this case, I just want 4 people. I don't care who they are. I don't care what order I pick them in. I just want 4 people. So that makes this a combination. So the way we're going to calculate that combination is we're going to take our total number of people, which is 64, and we are going to make a combination of 64 people where I choose 4 of them. So now let's go ahead and take a look at that 64 choose 4. So we're going to go to math all the way over to probability. If I do 64 choose 4, I end up getting, get this, 635,376. Can you believe that there's 635,000 ways to combine those 64 golfers? Imagine if you just happen to pick the perfect one where a group of 4 has a great game because they play well together, or you pick the worst one and someone like Tiger Woods is really off their game just because of the people you put them. How awesome is that, that we have that control? There are so many different combinations. Now, this kind of makes me want you to think about what happens with your teachers. So say you have 32 students in your class and your teacher says, I'm going to put you into groups of 4 for a project, and they tell you, I randomly picked them. And you're like, I hope that I'm in this group with my best friend Jimmy, my best friend whoever. My 3 best friends, we're all in the same class. We want to be in the same group together. What's the chance that that happens? Well, they're picking groups of 4, so this is just a combination. We've got 32 combinations of 4, or 32 people to choose from for a combination of 4. So let's take a look here. 32 choose 4. We end up with 35,960 different combinations there. So really think about this. If your teacher puts you and your 4 friends together, if this was truly random, you have a 1 in 35,960 chance that that would happen. So you know what really happens when you end up in a group with all your friends? That your teachers choose it for you, because there's no way that this would happen. There are so many possibilities of who you could be in a group with. And sometimes that doesn't include 1 of your friends or 2 of your friends. This is you and and your 3 friends all in that group together. So it's crazy when stuff works out that way. So that's the biggest thing. Remember, a permutation is where order matters. And when it comes to a word problem, that means that there's specifics we're looking for. When it's a combination, order doesn't matter. So it doesn't matter if I pick you first or if you get first or last. As long as you're in the top 9, you're moving on. That sort of thing. Or as long as you're in the first 9 to bat, I don't care where you are in the lineup. That's a combination, because we're not worrying about the order that things happened. We're just worrying about that they happened. And that's the biggest difference between a permutation and a combination. Feel free to reach out if you have any questions, but that is all about combinations and how to calculate them.